Welcome back to Rommel vlog, and also don't forget to like, share, and to subscribe. Hi guys, welcome to my vlog. In this video, we are going to talk about the continuity and discontinuity. So, when you say continuity is the informally continuous function, is one graph whose can be drawn without the pen or with leading paper, one with no hole or gaps. So, if our graph is with hole or gaps, it is called discontinuity. Okay? Okay, identify the function or the given problem if it is continuity. So we have also the continuity test. The continuity test is a function f is continuous at c if the following three conditions are satisfied. So the continuity test, we have three conditions that we must satisfy. We have number one condition, number two, and also the number three. So in our number one is f of c is defined. Okay, the f of c must defined in our condition or condition number one. So in our condition number two, limit x approaches c, f of x must exist. So in our condition number two, the limits of f of x must exist. Okay, in our number three conditions, the limit of x approaches c, f of x is equal to f of c. Now our condition number one and condition number two must equal. So if f is not continuous at c, it is discontinuous there. Okay. If our function cannot satisfy in our three conditions, it is discontinuous rather. This is the types of discontinuity. So we have number one, jump discontinuity. The jump discontinuity is the left and right-handed limits are not equal. Then the double-handed limits does not exist, or DNA. So this is the example or the graph of jump discontinuity. We have two we have two-handed, or we have two lines which is the left side and the right side, or this is not equal. Next, we have essential discontinuity. The essential discontinuity occurs when the curve has a vertical asymptote. This is called an infinite discontinuity. Okay, so be familiar what is infinite discontinuity or infinite graph. So this is the example of infinite discontinuity. We have the vertical asymptotes in its graph. Okay, next, the removable discontinuity. The removable discontinuity occurs when you have rational expressions with a common factors in the numerator and denominator. Because these factors can be cancelled, the discontinuity is removable. So, meaning to say, the removable discontinuity with the function or when you have a rational expression with a common factors. So if you have common factors in numerator and denominator, we can cancel as the common factor. So that is why this discontinuity called removable. So this is the graph of removable discontinuity, or the example graph of removable. Okay, let's proceed to in our continuity test. So we try to test if f of x is equal to x squared plus 2x plus 1 is continuous at 0. Okay, so in our first condition, we have f of x or f of c is defined. So let's plug in the value of x. So we have f of 0 is equal to x squared plus 2x plus 1. So we have 0 squared plus 2 times 0 plus 1. So this is 0 plus 0 plus 1 is 1. Okay. our first condition is defined. Okay, let's proceed to the second condition. We have limits of x approaches 0, f of x is equal to x squared plus 2x plus 1. So we have 0 squared plus 2 times 0 plus 1. So 0 plus 0 plus 1 is equal to 1. Okay, in our condition number 1 and condition number 2 is equal. So that is why in our condition number 3, the limits of x approaches 0, f of x is equal to f of 0, which is our condition number 1, and condition number 2 are equal. So the f of x, or the function, is continuous at 0. Okay, this function is continuous. Let's proceed to number 2. Determine if the following function are continuous at f of x is equal to 2 over x plus 1 at x is equal to 0 and x is equal to negative 1. So let's first identify or test if the x is equal to 0 are satisfied in 3 conditions. So in our first condition, we have f of 0 is equal to 2 over, okay, we plug in the value of x, you have 0 plus 1, and it is 2 over 1, so the answer of condition number 1 is 2. Okay, let's proceed to condition number 2. We have the limits x approaches 0, 2 over 0 plus, okay, we plug in the value of x, which is 0. So 0 plus 1, 2 over 1 is equal to 2. So in this function, the condition number 1 and condition number 2 are satisfied. So the condition number 3 is f of 0 is equal to limits of f of x, or limits x approaches 0, f of x. So the function is continuous at x is equal to 0. Okay, let's proceed to x is equal to negative 1. Okay, we try to plug in the value of x into the given function. So we have f of negative 1 is equal to 2 over negative 1 plus 1. So this is 2 over 0. So the condition number 1 is 2 over 0, which is 0. So the f of x is discontinuous at x is equal to 1. So we don't need to test or solve the following conditions, or condition number 2 and condition number 3, because our condition number 1 is already discontinuous. So that's all for today's video, and I hope you learned something. And also shout out to Henry Quintana. Don't forget to like, share, and to subscribe.